Hello everybody. Good afternoon or good evening. Welcome to Symposium 36. First of all, I'm not a native English speaker, so please forgive my broken English in advance. In this session, we are going to talk about to collect marine biodiversity data in DarwinCore format. Before starting the session, this is an announcement from conference committee about the presentation rule. Each presenter have 10 minutes for talk and 3 minutes for Q&A and 2 minutes and transition. For the online participants, please use the chat box to ask the question. For the participants in person, please use microphone for online audience. Short introduction for the session. This session will introduce activity in marine community, but all topics are related to DarwinCore handling. OBIS marine community is an intergovernmental activity under UNESCO aimed at collecting and integrating marine biodiversity data on global scale. Handling DarwinCore data is the most fundamental activity in OBIS. In the data cycle, key players are data player, and data provider, and OBIS and data users. We will share the experience on data-related topics to enhance the data cycle. Again, OBIS, what is OBIS? OBIS is a name of system name and program name, Ocean Biodiversity Information System. And we have 4 presentations. 2 presentations. 1 and 2 is related to data publication from the local government in Japan. And the 3rd and 4th is presented by OBIS node. OBIS node here have a very important role to contact data providers directly for smooth data publishing. And OBIS node also provides the technical information and information service to the data provider. They will share their experience with us in the presentation. Let's start my presentation as a first presentation. My name is Hosono from Japan. And this one is a co-moderator sitting here, Fujikura. And the 3rd one is a most important person. She is a staff of local government of Yokohama. I show the same data cycle here again. In OBIS activity, we usually conduct researchers belonging to the scientific community. But 2022, OBIS Japan have a slightly different experience. It was to assist data publishing by the local government. And there are 2 major topics in this presentation. One is about the data publishing by the local government, and topics 2 is follow-up communication after data publishing. Local government is also a policy maker, so they may become a data user in this data cycle. To enhance this data cycle, OBIS Japan node proposed to them to become a data user. A story on communication of Japan, OBIS Japan node with the city of Yokohama. Before data publishing and publishing, after publishing and follow-up communication. And robots from the data provider will pop up here. All contents of this presentation is based on the survey named Fauna and Flora in Marine and Rivers in Yokohama. So I explain background information of the survey. Yokohama City is located here. Can you see this one? And this area is a very highly urbanized and industrial area in Japan. The trigger of the survey was a serious coastal pollution problem in 1970s. So the purpose of the survey was evaluating environmental recovery. Before communicating with OBIS Japan node, the city of Yokohama originally hoped to announce the results of the survey widely. So they originally want to know a detailed process for standardizing their data. But the report of the survey has been published in the local government homepage in PDF format. They processed their data in 2022. They needed to generate digital data from paper media like this. They said the definition of DarwinCore terms are indeed difficult to understand well. But if anything, digitalizing this data from the paper media were more difficult rather than understanding DWC terms. This is their dataset page of OBIS, and the dataset was downloaded total 4,000 times from OBIS web page. So Yokohama City said they are very satisfied with this data level. In the next 5 slides, I will introduce follow-up communication between OBIS node and the Yokohama City. As everyone will know, DWC data can be easily integrated with the other DWC data. OBIS Japan suggested them to how to use their data with global OBIS data. And we also show some case study of detecting faunal change due to ocean warming. To detect ocean warming, it is critically important to compare with the past fauna. However, long-term data are usually not available. So Yokohama data set, that is a long-term monitoring data, is the most needed information now. So OBIS Japan use the detecting a faunal change as a case study. This is a schematic image of water current around Japan. Yokohama is located here, and there is a warm current from south and cold water from north. Yokohama, fauna in Yokohama are composed of both warm and cold affinity species. In the warmer situation, the warmer affinity species will increase. So faunal change due to ocean warming can be examined by comparing an optimal temperature range for each species in the species list of the survey. At first, we have to make a species list during the survey. This is a species list from Yokohama City dataset, and the circle indicates the present and cross indicates the absent. And then identify which species is warm species or cold species. Break down this process For one species, we have to collect and review references, and we have to extract information on distribution, and we have to estimate habitat temperature of the species, and repeat for all species. Much work is required to retrieve all information for all species. One solution for reducing much work is to refer global OBIS data. DWC data are easily integrated with the other DWC data using a short script like this. And data visualization is also easy by using small R library, a small R script. And this is the temperature range of this for each species, and this peak indicates the optimal temperature. When I explained this slide to the staff of Yokohama, I got a very detailed response. When I show this slide, their reaction becomes so minimal. But this slide shows some cold water species absent after 2006. But the key point is, did they really find the series of process is convenient? The answer is they said high flexibility in using our language are attractive, but generating graph by just clicking on web page seems to be more convenient. I agree. So summarize our communication to the Yokohama City is, I ask again, is the initial purpose of data publication achieved? Or is the number of downloads higher than you are expected? And I ask again, is it beneficial to analyze your own data with the OBIS global data? They said could be yes to all questions, but it is not convenient for me. This is my last slide. To promote to use the data by the local government, it is important to reduce barrier for data use. And we have to understand what kind of project they want. For example, we can approach this, their inconvenient situation. For example, OBIS Japan will provide a showcase of products like a simple map or estimate habitat temperatures, or we can provide a predicted movement against temperature change. And we can identify which type of products they need through further communication. And we will transfer technical knowledge to create products on their own by using this R script. This is my last slide. Thank you for my attention. And we have a time to Q&A. Okay, is there any question or comments? Okay, let's move on to the next topics. The next topic is Sakakibara-san and Kazu-san.
Hi, everyone. My name is Pauline, and this is my colleague, Mr. Sakakibara. And today we represent Toba City, and we will talk about the creation of a marine biology database that we published at the level of our city. So we come from a very small city in Japan, close to Osaka. So you have seen before Yokohama, so it's in the middle of Japan. It has a unique geographic feature, which is it's located in a bay. It benefits from a strong wind from the north, and it also benefits from the Kuroshio warm current. And all this results in a very rich marine life. It's also famous in Japan for ama divers, who are mostly women that free dive to catch shellfish and seaweed. They fish in a sustainable manner since more than 2,000 years. So I'm a lucky foreigner living in this city. But like everywhere else in the world, we notice that there is a decrease in marine biodiversity. So we start thinking how we could act on that. So we publish a book, a red list of endangered species. And this work has been done thanks to researcher, and currently we are working at the tourism division and the fishery division at my city together on it. So first, let me talk about what is this thing that we publish, this red list of endangered species. What's the purpose, who are the contributors, and what does it plan to achieve? So for us, publishing this book was very important as an indicator of our city marine biodiversity. It's a result of 3 years. It's like 13 researchers that gathered together and collected data from 2020 to 2023. And it registered various species, mammal, reptile, shellfish, including seaweed, which is very important to us because it's at the base of the marine ecosystem. This red list according to conservation levels. And it's not just a research list, it also includes insights from researcher, cultural notes, and state of research. So it goes a bit beyond research. And so from there, what we plan to achieve is at a regional level, we hope to gather, of course, other researchers from other research institutions. But a second point is also we hope to strengthen the cooperation on a more global scale. And this was done this year. This extra step was done when we published all this data published in this book on the OBIS platform that you have just been that Mr. Hosono presented you before. So now all this data is open source. Everybody can access it everywhere in the world. And of course, we hope as well that with this data, this research-based project, we will foster marine education for future generations. So I have talked about the research project, but actually this project goes way beyond research. And in Toba, we have a bit of unique setting at our city hall, which has been more than 10 years now that I'm coming from the tourism division and my colleague come from the fishery division. And we actually work since more than 10 years hand in hand because we realize that Toba, two main industries are tourism and fishery. And if we start working on our own, we couldn't go very far. So we need more synergies together. So we thought, okay, with this project, what can we achieve to go and to achieve a better sustainable development for our city? So, thank you. You see, always helping, all the time. So on the tourism level, what I can say is that we also notice that nature cannot be dissociated from culture. And so with this red list, we could come up with conservation measures. And this will help us to preserve the food culture and also the cultural heritage of our region. And then as well, we try to come up with kind of win-win situation. We try to put more value in the sustainable tourism industry. And so, for example, we will think more, we want to emphasize the quality of our seafood. So we know that for the tourist that comes, it would mean a higher price, but at the same time, it's very important for us that they understand the value that we put in this in the seafood, and that it's also it benefits for the local people, the local resident as well. A second example in the tourism industry is like, for example, promoting more ecotourism approach toward tourism. We hope that with this data, the tourists will understand how much it's important to us to protect the marine life at the level of our city.
Hi, my name is Tomoki Sakakibara. I am in charge of fishery promotion in Toba city. The situation of the fishery industry has changed in recent years due to the evolution in the marine environment, such as rising seawater temperatures, resulting in a decrease in the catch of marine products and in seaweed beds. With this situation in mind, we have several measures we expect to work on based on the red list and its data. First, there is various ecosystem conservation measures, like measures for habitat conservation. If we find the marine products have declined seriously, we can use this information for fishing limitations and creation of protected areas. Second example, a project to restore ecosystem. Restoration of seaweed beds and seagrass beds are essential because they are at the base of marine ecosystems. Another example is raising awareness among fishermen and citizens. The data can be used for lectures and studies and workshops at the Fishery Research Institute in Toba. I have talked about various ecosystem conservation measures, but these measures need to be balanced with the promotion of sustainable fishery. Fishing and preserving the ecosystem may seem to be contradictory, but a balance can be found with resource management and finding appropriate responses. Ongoing research and monitoring will allow us to regularly monitor changes in fisheries resource and ecosystems. Also, we can use regulation and plan strategy based on data, even if it's difficult to achieve, because it requires coordination with various people. Conclusion. The red list of Toba City is a database that supports the conservation of marine ecosystems, and therefore a sustainable economic development in the region by relying on synergies among industries and its people. It's a work in progress, and we hope we will inspire other cities to do so. Thank you.
Just a quick explanation. The last slide you have in the middle, so the data access that we publish online, so making available through the OBIS platform. And then on the right is the link to this book, but it's in Japanese. But just out of curiosity, I will pass it around. We have two.
Okay, we have much time to Q&A. Any questions?
Thank you for that. Obviously, that red book was based on a very extensive survey. Is there financial commitment from the city to continue that survey through the future as we expect things to be changing?
Yeah, so we cannot be 100% sure about if we look 10 years from now, how it goes. But of course, yeah, the plan is to put this project, to anchor the project in a long-term vision for the city and the regional development. So yeah, that's what we hope to achieve.
Any comment, questions, or online?
Thank you very much. So nice presentations. So I think that it is very hard work to make the red list in the local government. My question is, how many scientists contribute to the make the?
So it's in total 13 scientists.
Okay.
Yeah, from Mie, the prefecture, and Toba and other very close city that gather together to gather all the data.
Okay, thank you very much.
We still have much time to Q&A. Any questions?
Thank you for your talk. We were talking in the previous session about habitats, and you said you wanted to preserve some habitats and ecosystems. And I was wondering what, on what reference list of habitats you were based on in order to protect them. How did you identify which habitats you had in your city and how to protect them?
It would mean, like, for example, if we defined marine protected area, which kind of species we will mostly protect, or sorry.
Yeah, how you listed all the habitats that you had and how you decided which ones to protect or in priority? I was not part of the researcher listing all this data, but what I can say is that at the level of a prefecture, I know that the red list that I have show you contain, for example, seaweed and seagrass, which is something kind of new. It has not been done at the level of a prefecture, so we try. In our case, we'll try to look at also habitat that probably before were not seen as very valuable. But as you probably know, seaweed are very important, especially for marine wildlife. And this is very important for Toba City. So we have actually a research institute focusing on aquaculture. And seaweed in particular. So yeah, like I guess the prioritization, I'm not 100% sure how it was done, but yeah, it has been done, I guess, by the researcher involved in the project, how they will prioritize. It's very specific for us, like to speak today, because of course you all are expert in your area, and we are not, because we are not researcher, we are civil servant. But I think today what is really interesting is to see how we also realize that how we actually need to speak up and work more together and make all the wonderful work that you are doing, we have to make it more accessible to people and use it more. And so that's what we try to show with this project. So feel free to talk to us after the talk as well.
Thank you for your presentation. It's time to. Okay, let's move on. The next presentation is Sachit-san. Are you ready?
Good afternoon, Okinawa. So my name is Sachit Rajbhandari. So this session, the theme of this session is like how DarwinCore standard can be used to connect the local data providers to the global data aggregator. So I'll be showing some experience as a OBIS node on publishing marine biodiversity data. So this will be the outline for my today's presentation. So I'll be talk about OBIS Australia and then how we publish the data sets and show some use cases and some strengths and challenges of the work that we do and some takeaway messages. So OBIS Australia is a regional node of the OBIS. So it is hosted by the NICME. So NICME is the National Collection and Marine Infrastructure of the CSIRO. So CSIRO is again the Commonwealth Science and Industrial Research Organization of Australia. So OBIS Australia is the local data access point for the marine species distribution data for the Australian region and the adjacent sea. So within OBIS Australia, Australian Antarctic Data Center also publishes the data from the Australian Antarctic Program. So if you look at this diagram, so this is where the OBIS Australia sits. So there are two QR codes. So one which leads to the OBIS Australia's websites and other to the OBIS Australia IPT server. Next, I'll talk about the OBIS Australia publishing workflow. So we collect data from the various data sources, and the data that we collect are available in different formats, like CSV, some of them are Excel, some NetCDF. So what we do is we do the data transformation and formatting, and then we store those data into the local database. And beside this, we also do the taxon matching, which is a part of the OBIS node. And in the Oracle database that we use, we have a DarwinCore related table. So DarwinCore is the standard that we use for publishing the marine biodiversity data. So once we have a data in our local database, we can create the data metrics as well. And also we can do the data validation to check the quality of the data, which is the part of a data QC. And also we check the DarwinCore structure, whether the data is in correct format or not before publishing it to the IPT server. So IPT is an integrated publishing toolkit, which helps to publish the data to the global data aggregators. So once we publish the data to the IPT server, then the OBIS, global OBIS will harvest it, and then the data get published to the OBIS. And if the dataset is not available, is not already published in GBIF, then we register the dataset to the GBIF, and then eventually it gets published to the GBIF as well. So ALA is another local data aggregators, Atlas of Living Australia. So they also harvest the data from our IPT server. So if you look at here, the distribution of datasets, that's we have 486 total datasets, which has been published to OBIS. And these are the 36 million occurrence records that we have published to OBIS, and similarly to the GBIF and ALA. We collect the data from various sources. So new datasets mainly comes from the CSIRO MNF. So MNF is the Marine National Facility. So we have a research vessel that collects data, and then and also some other data comes from the CSIRO partners. Besides that, the dataset also comes from the publication and Australian marine researchers, and also from the repository from the Australian University. So these are some of the examples that we have. And if you see at this cloud, so it tells the list of institutions that has provided us the data. The size of the text tells that number of datasets provided by that institution. The one thing I would like to emphasize here is like we collect the data, we transform the data, and then before publishing it, we go back to the data provider and ask them to verify whether that data is ready to be published or not. So we do the data verification. Global ocean observing systems, they have identified the essential ocean variables. So what we have done here is like we have categorized our data sets based on the essential ocean variables. So here we can see that some of the highest number of occurrence is 21 million for the biomass and diversity, whereas the number of dataset counts for the fish abundance is around 227, which is the highest in this sector. So once we have the data and the metrics stored in our database, you can see here the metrics. So it tells us about the occurrence table, number of for any particular data sets, how many records are there in the occurrence table, how many there are in the events. It also tells us about the spatial and temporal distribution of the data sets. Besides that, about the taxa as well, information as well. So if you look at the map, provides the visual check whether the lat and long are valid or not. Sometimes what happens is that the data provided by the data provider, they forget to add the minus sign and the values, and then instead of the southern hemisphere, the data will appear in the northern hemisphere. So we can quickly check at the map and tell that, okay, there's something wrong with the data sets. So it helps us to identify those issues just before we publish the data sets. So that's one of the benefits that we have when you look at the data metrics. So here we have a list of checks that we do. Here we can see that some of the data records doesn't have the scientific name ID, so it alerts us before the publication of the data sets. So look at the DarwinCore structure. In the DarwinCore, we have the event core, occurrence core, and different extensions. So for any events, we have a sample taken at the event. In one sample, we have multiple occurrences, and there will be the measurement data, biotic and biotic measurement data that belongs to the event or occurrence. So all the measurements that are related with the events goes to the EMOF table. EMOF is the extension to the DarwinCore extension, extended measurement or facts table. So how we decide this, like whether to use the event occurrence or the event core or the occurrence core. So in the OBIS manual, they have provided a decision tree. So it helps depending on the data set to identify whether we should use which occurrence core and what extension should we be using. So for example, if there are more than one occurrence in any events, then we usually use the event as a core and then use the other occurrence. So here's the distribution. The table shows the distributions of all the event core and the occurrence core extension, and so there's a combination of various things. And so these are the data sets that we have and the occurrence. So it's just a table showing a different type of data structure that we use. OMS taxonomy matching. So OMS is another important factor is that we use the OMS taxonomy matching. OMS is the authoritative and comprehensive list of marine species, and OBIS uses OMS as its taxonomic background. So OMS identify the popular scientific name ID. So these are the steps that we take to identify the taxon matching. Some data sets, so there are some issues with things. So some data sets, they provide only the vernacular names or the common names. So there is no scientific names provided. So in that case, what we do is we look at the literature or we go back to the data provider and identify the scientific name. And in other cases, there are cases where we get the scientific name, but they are not available in the OMS. So we send those names back to the OMS and then to find the potential new names and add them by the editors. So I'd like to quickly go through some few use cases that we are currently working on. So one of them is the IMOS animal tracking data sets. So where we have a receiver is deployed under the water, and the tagged animals, they are detected once they get close to the receiver. So in this dataset, previously we used to publish this as an occurrence score without any events, but now we are following the TADWIC guidelines, which help us to identify the events. So in our case, we have the events like animal receiver, receiver deployment, and animal detection. So this is the flowchart that we follow to do this. So what we do is like we also get the summarized data in this. So summarized data information, we add them using the DarwinCore term called data generalization, where we tell that how the summarization has been done. So it tells the user about the data sets, how it was summarized. So other one is the DNA-derived extension that we extensively use to publish the eDNA datasets. We have published around 23 eDNA datasets and around 21 million records to OBIS. So one of the issues is with the DNA-derived extension that we face is like, so it used only with the occurrence core. It can't be used with the event core. So what happens with the measurement that are at the event level? So all the event level data has to be published at the occurrence level. So to avoid that data redundancy, what we do is we only publishes the measurement level data at measurement level using the different web services, not in the EMOF. Third example is the Mindoro Foundation as a publisher. So in this, we obviously Australia collaborate with ALA and Mindoro for eDNA data publication. So in this case, what we do, DarwinCore transformation is everything is done by the Mindoro themselves. So we allow them to be as a publishing organization. So we don't do any transformation in this case. So this is another example of how the data is done. So few strengths and challenges of our things is that we have a centralized data transformation process, and all the records are stored in the database tables before we publish. So it helps us to enable the thorough audits, check across data sets, and we have a data metrics. Let me talk about the challenges. So challenges is awareness of what we do and what services are available. So we feel that we are not publicizing much. So that's what we need to do. And also the TADWIC task group 2 test and assertion implementation, that's another issue. So TADWIC task group 2 has defined a lot of test and assertion. So there's the difficulty in implementation of that thing. So in the term of like whether the result of the test case can be, how can we associate those results into the records. The next issue is the ownership of the data publishing. So in some of the cases, we get the data from different groups and we do the data aggregation. So it's difficult to identify who is going to be the ownership of the data. So we have the issue with those things. And the other challenges is like parallel publishing path to OBIS and GBIF. So we want the data to be published, the same data sets to be published in OBIS and GBIF. So we don't want to have a redundancy that the same data gets published to OBIS and GBIF from a different channel. So to address few of the challenges, what we have done is we have enhanced the effort to communication between the communication and local collaboration between the local data providers. We are participating more into the conferences and outreaching to the data researcher and manager. And also we are organizing the capacity development by inviting the UNESCO internship student and also like SIRO vacation students to help them learn about the data publications, more in biodiversity data publication. And these things are done by promoting the OBIS manual, like asking them to join the training sessions, use of the OBIS GitHub repository, and the different tools that are available. And also we offer the one-to-one support for data publication. So the key, our takeaway message from this presentation is OBIS Australia advances the use of DarwinCore and related models for Australian marine biodiversity data. And our workflow is centralized data transformation, which ensure that high quality and standardized data are outputted. And we promote create once and publish everywhere. So we want the data to be created once and then the same data set get published to different data aggregators. So we support greater autonomy in data publishing. So to do that, we enable the data owners to develop the capacity to publish the data sets using the tool, manual, and training capacity. So as a final point, so we are the central hub for standardized and aggregated marine biodiversity data for Australian marine data. Thank you. So I'd like to thank the Catherine and Debwas, who is in our OBIS node team, for the support in making this presentation. Thank you.
Thank you for the presentation. And question or comment? Is there any question or comment? All right.
So we have two questions. So first one is from So Ishida. What data set, if any, are stored in OBIS Australia and have been collected by citizen science projects?
Sorry, what was the last?
So citizen science project?
Student science project?
Yeah, citizen science.
Okay.
Okay.
So any data sets that are related with the marine biodiversity, we store them, we publish them. So if any student projects, they have any kind of data sets, they can contact us and then we can help them to transform them into DarwinCore, which is the standard form to publish into the OBIS. So we can help them publish them to the OBIS.
Okay. So next question is from the Ruben Perez. So thanks a lot for great presentations.
Thank you.
So could you please explain again, how do you bypass the redundancy of the documenting measurements at event level in the data set without event tables related to the eDNA data sets?
Yeah. So let me explain that. So as I said, DNA derive extension is not compatible with the event. So any measurement that are at the event level, so will be, so in any, let's say for example, we have an event and then in one event we have 100 million occurrences. So for one measurement, we'll have 100 million records. So that's going to be the redundant. So that we don't need that things to be repeated again for each occurrence level. So that's why what we do is we keep the event level measurement in a different file, and then we publish them as a web services so people can access directly at the event level. So that's how we do. So that's something what we do different than others.
Okay, thank you.
Time is okay? Time to come. Okay, thank you for the presentation.
Thank you.
Let's move on the last presentation, our session. Is it okay to change? Ruben,
Hello everyone, and thanks a lot for having me. Today I come to celebrate with all of you the 20th anniversary of the European Ocean Biodiversity Information System, or EurOBIS. During the next 10 minutes, or about 10 minutes, I'll share with you where did EurOBIS start and what have we learned in all these years. My name is Ruben Perez, and I work as a data manager in VLIS, the Flanders Marine Institute in Belgium, with a fantastic team of people whose names you can see on the screen. But first of all, what is EurOBIS? EurOBIS is a European data aggregator of quality control marine biological occurrences and associated data. What does this actually mean? It means that we mobilize, rescue, and gather data from many different sources in Europe. It means that we adhere to and promote the use of international data standards, such as DarwinCore. It means that we have a specific habitat expertise and scope, which is the marine environment. And it means that we gather comprehensive biodiversity data, such as organism quantifications, biometrics, and characteristics of marine wildlife occurrences, coming from varied sampling methodologies and often accompanied by environmental information. As its name hints, EurOBIS operates as a very active OBIS node, having gathered by now more than 1,300 datasets and more than 40 million occurrences records. Although, to celebrate the 20th anniversary of EurOBIS, we do have a surprise for you, which is on our media profiles, so keep an eye on it. But where does EurOBIS come from? How did EurOBIS start? EurOBIS was originated in Belgium, within the Flanders Marine Institute, and under the framework of MARBEF project. The MARBEF project was a European initiative partly focused on the integration of marine biodiversity data resources. The aim was to create a data collaboration framework for European marine biodiversity researchers. In this context, EurOBIS was born with its first data acquisition in summer 2004, nothing less than 20 years ago. Its first objective in terms of which types of data would be gathered focused on very basic biogeography. Back in those days, a scientific name, a location, and a date was more than enough. With a clear objective in mind, EurOBIS developed an evolving set of strategies to find all that scattered data and collect it. The first part of the strategy was locating the institutes, projects, initiatives, and people that had already started aggregating data in some way. At VLIS, we were already aware of some internal and regional databases that had been collecting data for some time already, so we started making these databases public as a pilot. After a few years gathering some of the existing large European databases, EurOBIS became an integral part of those regional networks, and soon after it turned into the preferred and then required data repository for European marine biogeographic occurrences data, constituting the data backbone of newly created long-term initiatives such as EMONET Biology and then LifeWatch, which would start funding the EurOBIS data management and service development efforts up until today. The second part of the EurOBIS strategy was aimed to promote and facilitate data sharing. It had to do with all those scientists that either fell outside of the GBIF OBIS umbrella or that didn't know how to publish this data. The networking efforts turned very soon into raising awareness conferences about the importance of data sharing. They turned into news messages and media posts. These then turned into hands-on workshops, online courses, and hackathons, and eventually even into the development of data services to quality control data, for example. Over the years, our way of working and communicating had to change, from gathering what was available to convincing people to adhere to new open data trends, from being data experts to becoming people's experts, without, of course, losing track of all the new developments that were happening in the data world. The ratification of DarwinCore by Tedwig and the data sharing technologies such as the Integrated Publishing Toolkit, of course also known as the IPT, turned static data files sent via emails or FTP servers into semi-automated data flows. And soon, our data users were asking us for more data, better data. So we became a mediator between data providers and data users and made it possible. Standardized organism quantifications, characteristics and biometrics, explicit sampling methodologies, and abiotic data were added to the datasets, making them richer. However, the limitations of the DarwinCore star schema made these datasets quite redundant. So at that time, we pushed DarwinCore to the limit by helping create the extended measurements or facts extensions and combine it with EventCore datasets. This approach would hack the star schema into small relational databases, making them simple enough to be created by the data providers, but complex enough to contain all the data the users needed in an organized way, finding the right balance. Legacy data, quality control, scalability, data gaps, data deduplication, and constantly appearing new types of data became those monsters that we had to fight, and we do keep on fighting them today. Our best weapon has always been the technological collaboration of a committed community, and our biggest strength, it's been a human understanding of the needs of data providers and users. Since this presentation is a celebration, I'd like to make a toast for all those data providers. First of all, the perfectionists, which always push our limits in one way or another, sometimes suggesting better technologies, sometimes just criticizing current workflows that are flawed. They make us learn with their knowledge and expertise. The enthusiasts, always fun to work with. They want to see the best and only the best version of the datasets, and they will move heaven and earth to get it done. Their passion is our fuel. Of course, the pragmatic minimalists. They're usually committed to their deliverable. They draw very clear boundaries on what is expected from them. Thanks to them, we learn to be explicit and specific in our manuals and project proposals about what is needed, what is expected. They help us to be clear, making life easier for future generations of data providers. And last but not least, the legacy heirs, or the archaeologists. In a way or another, they have inherited or rescued data from the past. They usually carry labels and symbols that nobody understands, but always hopeful that one day the miracle of technology will translate their gibberish. They are the driver of the fair data movement, helping us see in the present what will not be understood in the future. All of them, at their own pace and expertise, are part of the data sharing movement, and all of them deserve our support. Therefore, what we have learned in EurOBIS after all these years is to stay flexi, is to adapt to the needs of our data providers, because they will be very varied. Some of them will just need us to facilitate them a manual or a training course, and they will do the rest. They'll take it from there. Others will need a video call or a meeting to actually make things clear. Some will ask us to completely readjust our data systems to allow for full automation, and others will just ask for reminder emails. Some will request the creation of tools to fight the quality control monster or to choose the appropriate control vocabularies for them. Some others will just need a chat group or a forum to create their own collaboration network. And for all of them, there will always be a data manager assistant to ask the difficult questions, to guide them through the data publication struggle, and like today, to celebrate the 20 years of marine biodiversity data management. Thank you very much, and have a great day.
Thank you very much for your presentation. Can you hear me?
And hello, yeah, I can hear you. Can you hear me?
Can you see me?
I can only see, well, I cannot see the room. I can just see the letters, the OCC room B3.
Ruben-san, it's start Q&A time. Is it okay?
Yeah, that's all right.
Any question or comment from floor or online? Can I ask you from my... Can you hear me?
Yeah, absolutely. Yeah.
I have a small question. EurOBIS have a very huge data every day, every year published. So are there any secret method to get new providers?
Thanks a lot for the questions. I think the answer would be related to always collaboration. We've always been gathering data from all the outreach that we've been doing, and also the network that we've been creating. So we are in contact with a number of other European marine institutions that also gather data in their local environments to provide it to us. So this is probably the major strength, which is powered by the project, the initiatives that I've highlighted before, like EMONET and LifeWatch. So in short, my answer would be collaboration. You need to make yourself heard, and for that you need a lot of outreach. So whatever works in your area, social media or news messages, or just the mouth to mouth. In some places it works really well, but really collaboration. Because once people understand what the need is and the messages, they like a lot of people become happy to collaborate and they join into the open science movement.
Okay, thank you. Any other comment or questions? Online.
Yes, online. So Sato-san, can you hear me?
Yes, thank you very much for asking.
So is this a question for the Ruben?
No. This isn't information about the book in Toba.
Okay,
Yeah,
this is a general comment for the
Yes,
audience.
yes.
Okay, thank you.
Thank you.
Just a moment, please.
Can I ask again? Could you show me the slide of the categories of providers? Can you show the slide? It's okay. You said 4 type of providers. One is enthusiast.
Yeah.
It's a maniac people.
I wouldn't say it's maniac, more like people that may not have all the knowledge, but that they really want, and they agree with all the suggestions that we give them. There are a lot of people that just want to give us data, but they don't know how. So they let us guide them through the whole process of transformation of data, quality control, and publishing.
Okay,
So I call them enthusiasts because they're always happy to help.
Okay, many participants joining this conference are categorized as enthusiasts. Is it right?
I would say so. I would say a lot of people in that conference in TEDWIG, and I'm sorry for not joining personally, are both enthusiasts and a lot of them perfectionists and quite experts. And yeah, absolutely.
Okay, thank you. Thank you for clarification. Any comment on the question? Just last time to ask him. Oh, no. Okay, thank you, Ruben-san. It's time to close this session. That's all for our session.
Okay, everyone. So we have one comment from the Sato-san related to the second presentation. So Sato-san, can you hear me?
Yes.
Okay, so please speak your comment.
Okay, thank you very much for asking me. One of the audience about the protection about the data book, but I'm happy to share to give information about the book about Toba, one of the planner of the OSA. as presentation at the beginning, there are many negative factors such as global warming, water pollution, disappearing the sewers, the pollution of the resources, and the various other negative factors caused by the people, and kind of the situation. So City Hall is in the process of taking the measure to address these issue in its local policies. We have included my hint for this in the data book as well as information about in this data book. The bismuth is one of the utilized for the information in living creatures, but I feel that it's necessary to share and increase literacy in different way about the Satomi. I wrote about my book, the book, the viewpoint and information to organize the history of the Japanese relationship with the ocean. So to the more effective platform, or I think Bismal is enough, but I would like to see the establishment about the national office and would serve as counterpart to the government and researchers and discuss how to utilize the information and incorporate its into policies as the next step. Of course, keep monitoring. Yes, thank you. Thank you very much.
Okay, thank you very much.
Thank you. Comment to the red list data books. That's closing time now. So everyone, thank you for attending this session, and thank you very much.
I work in Annapolis Museum of Science, and so we are embedded in Los Angeles, which is part of large amounts of long-term monitoring that go on. It started in the 1970s.
Yeah, I was going to say, or it looks like 3 years.
Well, but a lot of it started in the 1970s because of federal legislation that mandated that the wastewater treatment facilities all had to start monitoring their effect, because at that time before it was raw sewage going out, and they needed to fix that. So there's been this regime of bionic sampling non-stop since the 1970s, up and down the entire California coast, which has been remarkable, and the environmental conditions have improved amazingly. But the monitoring keeps going because it's demanded by law. And so there's, which is good. Yeah, I know, it's really good. And it's had really good